What is cosmic radiation? By Blair Pusho, Star Hernandez, Sadie Duthu, and Zeke Guidry.
It's many things. Brent Nelson, MA in physics, said it best by explaining, cosmic radiation is a collection of many different types of radiation from many different types of sources. When people speak simply of cosmic radiation, they're usually referring specifically to the cosmic microwave background radiation. This consists of very, very low energy photons, energy of about 2.878 Kelvin.
Is it dangerous, and should we be concerned?
Not really. The Earth is pretty adequately protected from most cosmic radiation, such as galactic cosmic rays coming from the outside the solar system, anomalous cosmic rays coming from the interstellar space at the edge of the heliopause, solar energetic particles associated with solar flares and other energetic solar events, and the term cosmic rays used to include X-rays and gamma rays.
This is a model of what the Earth's shield looks like against cosmic radiation. Scientists today are currently trying to work on a way to artificially create this type of shield in order to protect spaceships for further space exploration in the future. The only form of radiation that is a danger is solar radiation. The radiation to worry about, of course, is the cosmic radiation produced by our sun. There's only one type of cosmic radiation known to adversely affect us, and that's UV radiation, which causes skin cancer in millions of people each year. Again, our atmosphere serves as a shield, but ultraviolet photons do make it through, and without the protective ozone layer, which blocks these photons, we're all going to need a lot more sunscreen.
Most energy on Earth comes from the sun. Solar energy travels through the vacuum of space to Earth by a process called radiation. Radiation is energy emitted by an object, like light from a light bulb. Radiation happens at different wavelengths. The hotter the object is, the more energy it radiates at shorter wavelengths, from longest radio waves to shortest highest energy gamma rays. Light bulbs can be used to illustrate the solar radiation that reaches Earth. Although the sun's peak output is at visible wavelengths, most solar energy reaches us as infrared radiation that we feel as heat. Think of the night lamp in a reptile cage. Next, we get hotter, higher energy shortwave radiation that we see as visible light and different colors at different wavelengths. A lesser amount of even higher energy ultraviolet radiation reaches us. Think of black lights and tanning beds. We can't see or feel UV radiation except by the damage it causes, such as sunburn and fading fabric. Luckily, our atmosphere protects us. In the stratosphere, higher than Mount Everest, a gas called ozone acts like sunscreen and filters out most UV radiation so that even less reaches us at the surface. Most energy on Earth comes from solar radiation. We see the fraction that reaches Earth as visible light, we feel the infrared portion as heat, and we notice the harmful ultraviolet rays when we get a sunburn. For more information, visit climatebits.umd.edu.
So where do these rays come from? All luminous objects can produce radiation. Photons of all different energies or wavelengths are being created by our sun, other stars, quasi-stellar objects, black hole accretion, disks, gamma ray bursts, and so on. These objects also produce high-energy massive particles such as electrons, muons, protons, and antiprotons. These higher energy particles are potentially dangerous, but most of these particles never make it to the Earth. They are deflected by magnetic fields between us and the source, or they interact with other particles, or they decay in flight. If they were really that harmful, we couldn't be talking about them today.
Here are a few illustrations of different places where solar radiation comes from. The first is supernova shock waves. The second is the heliosphere, which is ionization of local interstellar medium. And of course, the sun or coronal shock waves.
If we leave the Earth, though, then we would need to worry about protecting ourselves from the various forms of cosmic radiation, such as the use of spaceships and astronaut suits.
So basically, most cosmic radiation is formed by the explosion of stars, and it sticks around for a long, long time, since space is infinite. The only known cosmic radiation to harm humans directly comes from the sun.
Thank you for your time, and remember to wear sunscreen.
And this is also a list of all the sources we used for our information, photos, and videos.